Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 6 from the October 2024 International A-Level Edexcel Pure Mathematics P4 exam. And we're asked here to do integration by substitution. And they've told us to use the substitution u equals the square root of x cubed plus 1 to show that the integral of 9x to the power 5 over the square root of x cubed plus 1 with respect to x will give us the answer 2 times x cubed plus 1 to the power of k and times x cubed minus a plus c, where we have to find k and a, and c is obviously the constant of integration. So here we have to use substitution. So the way that I like to deal with integration by substitution is as follows. So our objective is to integrate y with respect to x. That's our objective. And we have to do it by introducing a third kind of variable here, which is u. So in order for us to do this, what we can do is we can say, okay, this is equivalent to doing the integral of y times dx du with respect to u. You can think about these two cancel out, leaving you the same thing as that. So y is basically the function that we have to integrate, which is this. This is the y. And dx du is the expression we get when we differentiate x with respect to u. So here we have u is equal to the square root of x cubed plus 1. Now, the easiest way to deal with this, I think, is, if I integrate this, if I differentiate this, I'm going to get like a bit of a complicated kind of expression. So what I'm going to try and do is I'm going to square both sides to get rid of the square root. So this will be u squared equals x cubed plus 1. Subtract 1 from both sides. I'm left with x cubed is equal to u squared minus 1. Okay. And then I want to find dx du. Right. So what I can do is, in fact, you know, the easiest thing to do is to find du dx. Why? I can use implicit differentiation. If I integrate both sides of this with respect to x, I'll have 2u times, and then I have to put du dx. Okay. 2u times du dx. And this will be, if I differentiate this side with respect to x, I'll get 3x squared. So I'll end up getting du dx is equal to 3x squared over 2u. So dx du is going to be 2u over 3x squared. Let's see how this pans out. Okay. So we're going to have here, this is going to equal the integral of, now y, if I take my y is equal to 9x to the power 5 over the square root of x cubed plus 1. And they've told us to replace all of this with u. So this is going to be 9x to the power 5 over u. Right, so I'm going to write it out like that first and see if anything cancels out. So I have 9x to the power 5 over u. Okay, that's my y times dx du, which is 2u over 3x squared. Okay, 2u over 3x squared. And then I've got du. So the x squared here cancels with this. That gives you x to the power of 3. And I need to get rid of this x to the power of 3. So far what I've got is I can take the 3 and the 2 and the 9 cancel out to give me 3. So I have 3 times 2, which is 6. These u's cancel out as well. So what I'm left with 6 times the integral of x cubed du. But I have to make this in terms of u, which actually is going to be quite easy. Why? Because I have here x cubed. If I rearrange this, I have x cubed is equal to u squared minus 1. X cubed is equal to u squared minus 1. And I can replace x cubed with u squared minus 1 to have 6 times the integral of u squared minus 1 with respect to u. Okay, so that became really easy, right? That became quite easy. Okay, so yeah, so that's how I've dealt with this question so far. The only thing that some people might be a bit, this is using implicit differentiation. Okay, I could have come to the same, or come to an answer which would lead us to the same thing by, for example, making x a subject. But then you see what we'd get. We'd have x cubed equals u squared minus 1. And then I would have x is equal to u squared minus 1 to the power of a third. And then when I find dx du, it's going to be a half times u squared minus 1 times 2u. They cancel out. You have u times u squared minus 1. And that will be your dx du. Okay. And you'll end up getting the same thing in the end, actually. Right? So whichever way you prefer, it will work. Okay. It really doesn't matter. But I find this is a bit simpler to deal with. If you know how to do implicit differentiation, it's less messy than that. Okay. And you end up with the same thing in the end. Okay. I can show you, in fact, in a neater way, how to get to the same stage using the method that I just mentioned here in a bit of a neater form, so that just in case some of you would prefer to go that way, that's fine. So supposing you wanted to end up with the same thing, but you wanted to do it in a slightly different way. Okay, at this stage, you could have said x cubed is equal to u squared minus 1, as we've done there. So x is equal to u squared minus 1 to the power of a third. Okay, to the power of a third. So dx du would be basically a third times u squared minus 1 to the power of minus 2/3. Okay, and then that would be dx du. Okay, so we would then have our y, which would be 9x to the power 5 over u times dx du, which would be a third times u squared minus 1 to the power of minus 2/3. Okay, and du. And the x to the power of 5, okay, we can say x to the power of x is equal to u squared minus 1 to the power of a third. So x to the power of 5 is going to be this raised u squared minus 1 to the power of 5 over 3. Okay, so you see how it's getting a bit messy now. So this would be the integral of 9 times u squared minus 1 to the power of 5 over 3. Okay, over u times a third times u squared minus 1 to the power of minus 2/3 du. And then when you add these two powers together, okay, when you add these two powers together, you get 5 over 3. That's going to give you 3 over 3, which is 1. So you end up with the 3 cancelled with a 9, leaving you with a 3 here and a 1 here. And this gives you, times 2u. Forgot about the times 2u. So the u cancels with the u. Okay, and we got 2 times 3, which is 6. And these two give you u squared minus 1 to the power of 1 du. So you get exactly the same thing. I forgot here, when you differentiate this, you're going to get, a third times u squared minus 1 to the power of negative 2/3 times 2u. All right, so you have to multiply by the 2u here. So the u cancels with the u, the 3 cancels with the 9. 3 times 2 is 6, so you have 6 outside here. And then these two, when you add the two powers together, because they're the same base, u squared minus 1, 5 plus 2 over 5 over 3 plus 2 over 3 is going to give you, so 3, that's going to give you 3 over 3, which is 1. So we end up with the same thing. I think this is a lot more messy than what I did there. And using implicit differentiation made things a bit easier, I think. As you wish. But in the end, we get to this stage, whichever way you chose to use. So I'm just going to get rid of this just to save some space. Okay. and we will continue. Okay, so now we have to integrate this with respect to u. Okay, so we end up with 6 times, and we'll have u squared, which is u cubed over 3 minus u, and of course plus c. Now what we have to do is we have to take our u, which is the square root of x cubed plus 1, which is like x cubed plus 1 to the power of a half, and put it back into here. So you have 6 times, equals 6 times, you're going to have x cubed plus 1 to the power of 3 over 2 over 3 minus x cubed plus 1, okay, to the power of a half. You're going to have plus c. Okay, so if you expand this, you're going to have 6 times this, that's going to be 2 x cubed plus 1 to the power of 3 over 2 minus 6 x cubed plus 1 to the power of a half plus c. We're almost there, but here we have separate terms, here we have one term. So what has happened is these have been factorized. Okay, you have factorized these two brackets. And how do you deal with factorizing brackets like this? Well, we have to think about, first of all, the common factors in these two terms are 2 from the numbers, and then from the brackets, the highest common factor is the one with the lower power. The highest common factor is the one with the lower power. So I'm going to write outside x cubed plus 1 to the power of a half. And then I'm going to open my bracket. So this times something gives me that. Well, the 2 is already there. I don't need it. But what do I have to do to make this become that? Okay, as we know, when we multiply two terms together, so I have a to the power of a half times a to the power of blank equals a to the power of 3 over 2. I have to add the two powers together. And how do I have to multiply? What do I have to add to a half? To give me 3 over 2, I have to add 1. So I have to basically multiply this by x cubed plus 1 to the power of 1. That's going to give me, if I multiply these together, I'm going to give me that, right? And then I've got to find out what I multiply this by to end up with this. Well, I need a minus, I need a 3, and that's it, because this is the same as that, right? So this times that's going to give me minus 6 times x cubed plus 1 to the power of a half. And then I've got my plus c. So I have here 2 times x cubed plus 1 to the power of a half. And this is going to be x cubed minus 2. 1 minus 3 is minus 2. And then plus c. And is that the form we need? Yes, 2 times x cubed plus 1 to the power of k. So k is a half. And x cubed minus a. So that means a is equal to 2. Okay, so we can see here that k is equal to a half and a is equal to 2. So this is the form that we need for our final answer. And there we have finished this question. So there's a few different ways, as I said, we could use the substitution. I don't know if some people do this in a slightly different way than I do, but whichever way you do it, this is what you have to end up with. Okay, as I said, I prefer to use implicit differentiation here. I found it made things a bit neater, but the other way that I showed you is also perfectly valid. So there's the answer to question number 6. That's basically quite, it's only 5 marks, quite short question. I think that's why this paper has 10 questions on it. Anyway, that concludes this question from the October 2024 Pure Mathematics P4 paper. Other questions from this paper can be found in the playlist that will appear on the top right of the screen at the end of this video. Other questions from integration by substitution you'll find in the playlist that will appear at the bottom of the screen here. Other questions dealing with integration from P4 in general you'll find in this playlist, and you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.